Alright, so the first thing we need to do here is actually form a differential equation, okay? And we're being told the rate of an investment in art appreciates depends on the value of the piece of art. So, in other words, the value, the rate of which the value is changing, is actually proportional to the value initially, okay? And I'm just using I. We'll talk about that in a minute, okay? Because I will be that rate of appreciation of the picture, okay? You could use K, you could use any letter you want, okay? So now we've got ourselves a differential equation. We want to actually work out what was the initial, okay? So we've been given that initially in 1990 it was 12,500. So I want to integrate. I want to actually make this into a differential equation. I make I p dt. So I'm just multiplying through by dt. I'm going to take the p over to the other side. 1 over p dp equals I dt. Okay. That means natural integrate both sides. That means natural log of p equals IT plus C, okay? So if I take E to both sides, I have E equals, take exponentials of both sides, E to the IT plus C. Now, that actually can be rewritten, because this here is E to the IT times E to the C, because when you times, you add powers, so I can actually call this E to the C another number. And it turns out, and you'll find this quite often, that is the initial value. So we're going to call that P0. Okay? So E to the power of C, P0 equals E to the power of C. Okay? So that's E to the power of a constant. So it is a constant itself. And that's times E to the power of IT. Okay. So what happens when t equals 0? Okay? When time equals 0, we've been given, P, we've been told is 12,500. Okay, so when we initially bought it, it's 12,500. P0 e to the power of I times 0. So this is that there is 1 anyway. So you want to be able to that function there is 1. So we end up getting ourselves in a position where we've got 1 times P0 is 12,500. So P0 is 12,500. So the price is equal to 12,500 times e to the IT. Okay, we want to know I. Okay, so we've been told that 5 years later, so when t equals 5, the price is 14300. So all I'm going to do is e to the I times 5, so the 5i. So I divide these two, so I end up getting 1.144 equals e to the 5i. So I've just divided through by 12,500. That means if I take natural logs of both sides, natural log of 1.144 is equal to 5i. Okay, I divide through by the 5, and I'm going to get, so I will end up equaling natural log of 1.144 divided by 5. We actually just shove that into our calculator, and it's 0.0227. Okay, 269 if you want to go a little bit further. Okay, so that's 2.7% per annum. Okay, so it's actually changing. The rate of appreciation is actually 2.5%. All right, so sorry, 2.7%. So what we've been doing, let's just go over this whole process again. This I is the initial, is actually the rate of which the investment appreciates, okay? Because that's the proportionality compared to what I said, sorry. This whole thing is the rate of which it appreciates. This is the initial cost, so that must be the interest, okay? Because it's changing as the interest increases, okay? So it's getting added on. So all we're doing is following that process of solving a differential equation, and then this is just algebra. Okay. This exact type of question will turn up so many times. Like it will be, it won't look exactly like this, but it may look like dy dx is equal to, sorry, dy dx, dy dt equals to kt, and that will always kind of come to this kind of solution. This here will always keep coming up, that whether it's these values will be different, they might be whatever your context is, but it's always going to be that same process, all right? So practicing questions of this format, you can pretty much guarantee you're going to try to get a question like this, or of the other forms that I'll show you in class in the exam.